Okay, this is graphing functions a to the x and e to the x with transformations, including a discussion about e. And you're going to do 29 through 36 flip. Basically, it's a matching thing. But let's just go over graphing a little bit. Okay, so when we're talking about a to the x, we're talking about with a is bigger than 1. And we're also talking about, so a to the x, where a is bigger than 1. And we're also talking about a to the x, where a is in between 0 and 1. Okay? So they're different things. And then e to the x is, we'll talk about shortly. We're also going to do some transformations, some quick transformations, because once you have these down, you're pretty good. So the first one we're going to go over is y equals 2 to the x. And I did a table of values, and if I plug them in, and you need to know basically that, let me erase some of this, put it down here. You need to know that 2 to the negative 3 equals 1 over 2 cubed. Remember that negative flips it down to the denominator, which is 1/8. You remember that from Algebra 2? So this is 1/8. And then 2 to the negative 2 is going to be 1/4. 2 to the negative 1 is 1/2. And then, I don't know why I wrote it like this. Let's see. Let me rewrite this as 2 to the x, and then we were going to do 3 to the x on the same page. 2 to the 0 equals 1. Remember, this is your y-intercept. Okay? And then we have 2 squared is 4, and 2 cubed is 8. So you can kind of see the reciprocal part going with the negative exponent and the positive exponents. Okay? So if I'm going to graph this, I'm going to start down in here and do this part first. So 0 goes to 1, 1 goes to 2, 2 goes to 4, and 3 goes to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, if I graph this, it goes like this. I'll do it in green. Alright, and then let's do some of the negatives. Negative 1 goes to 1/2, so that's there. Negative 2 goes to 1/4. Negative 3 goes smaller, so it's going to get smaller and smaller and never cross the y equals 0 line. So this has a horizontal asymptote at y equals 0. And let's look at the end behavior. As x approaches infinity, so as this is infinity over here, as x approaches infinity, f of x gets larger and larger. Okay? And as x approaches negative infinity, we get closer and closer to 0. So this is negative infinity over here. Just know what the graph looks like. Now if we do 3 to the x, we're going to get the same thing, but it's basically anything to the 0 power equals 1. So if I do 3 to the 0, that's going to be 1. So we still have the same y-intercept. But when we do the negative 3, that's 1 over 27, 1 over 9, 1 over 3, and then we're going to get 3, 9, and 27. So I'm going to start on this side because it's easier. So 1 goes to 3, 2 goes to 9, up in there, and so forth. So it goes up a little quicker, and it's also going to go down quicker to 0. So it almost looks the same. And the rest would be the same. 4 to the x would even be closer in. right? It would be closer in, and 5 to the x. It gets closer and closer to the y-axis. So that's your graph of y equals 2 to the x. Let's do the ones that where a is in between 0 and 1, i.e. that it's a fraction here. So basically, I'm going to do -3, -2, -1, 0, 0. Anything to the 0 power equals 1. So the y-intercept is always 1, right here. And we're going to do 1, 2, and 3. So 1 would be 1/2. This is your x. This is your 1/2 to the x. This would be 1/4. This would be 1/8. Now, for the negatives here, so 1/2 to the -1 is actually 2 to the first power. Because remember, this -1 just flips it up. So that's going to be 2, 4, and 8. So what happens here is if I plot it, 1 goes to 1/2. It's going to, and negative, I'm going to do this side because this side's easier. -1 goes to 2. -2 goes to 4. 3, 4, there's 4. -3 goes to 4, 5, 6, 7, 8. So basically, it goes this way. So, and you could do the same thing with 1/3 and all that. So look at the difference. It reflects over the y-axis. So know those kind. Okay? And same thing, horizontal asymptote is y equals 0. Look at the end behavior. As x approaches infinity, f of x goes to 0. As x approaches negative infinity, f of x gets bigger and bigger, so that approaches infinity. Okay? Now, let's do -2x. So we already knew what 2 to the x is, so let's do 2 to the x real quick. Move this back to blue. 2 to the x, we had 1, 0 goes to 1, 1 goes to 2, 2 goes to 4, and so forth. It was like that. Right? Something like that. That's y equals 2 to the x. The -2x basically is going to be a reflection over the x-axis. So you reflect it, we're going to get, do a table here. We're going to do -3, -2, -1, 0, 1, 2, and 3. So basically, remember PEMDAS. So I always like to do the y-intercept first. So -2 to the 0. You have to do the exponent first. So 2 to the 0 is 1, so you get -1. Alright? And if you do to the -1, well, let's do 1. If you go to 1, that's going to be -2. 2 is going to be -4. And 3 is going to be -8. And so you can infer the rest. -1 is going to be -1/2. And -2 is -1/4. And -3 is -1/9. So this one, we're going to go 0 goes to -1. 1 goes to -2. 2 goes to -4. 3 goes to -8, somewhere down here. So it's going to be like this. Okay? And that's the negative. And then you could also, this is y equals -2 to the x. Okay? Alright, next one. we're going to do e to the x, and we're going to talk about e to the x. First of all, e to the x came about because you've seen this formula before. If you have, it's defined as the expression 1 plus 1 over n to the n. And what I like students to do is just to plug in tens. So if you do a table of values for this, so we have x, and I plug in 1, and then 10, then 100, then 1,000, then 10,000, and then 100,000, and then 1,000,000, and so forth. And basically what I'm saying is e equals the limit as n approaches infinity. So let's let this be n instead of x here. And as this gets bigger and bigger, what does this number come to? So when you plug in all these values, basically you're going to get 2. 10 would be 2.59 something. 100 would be 2.70, and so on. 2.71. 2.71. The 1,000 is 6. This would be 718. And basically you get you get kind of the same thing here with a bunch of digits after this. So basically, if you think about e as being 2.718. So it's really, when you're graphing y equals e to the x, you're really graphing y equals 2.7, or approximately 2.178 to the x. You already know how to graph y equals 2 to the x, and you already know how to graph y equals 3 to the x. So it looks just like those, just in between those two. Okay, so when you have y equals e to the x, basically you're going to have 0, 1. 1 goes to 2.72, or 2.72, which is in between here. So 1 goes to 2.72, and 2 then would go to 7. I'll put it right here. I'm not sure, but let's see. 2 goes to, I'll put it right about here. 2 goes to 7.39. So basically, it looks just like the others, and you could do the others. You need to know basically negative 1 goes to 0.37, or 0.37. And if you know these two values here, that's going to help you, because we get to do logs, and logs are the inverses of this. So we're going to switch the values. So do you see it's the same thing? It looks just like, let me go back. It looks just like this one, right? Okay. Same numbers and everything. Okay, let's do a few transformations. I'm going to transform y equals 2 to the x plus 1. Alright. Basically, you already know what, let's do in purple, y equals 2 to the x. I don't know why I keep putting it down there. Okay, y equals 2 to the x. So, we know our y-intercept is 1. 1 goes to 2, 2 goes to 4, and then 3 goes to 8, somewhere up in here. So we know what this is. That's the parent function. So basically, y equals 2x plus 1 is you're just shifting it up by what? By 1. So you're shifting up everything by 1. I'm going to shift this up by 1. I'm going to shift where? Right here. And I'm going to shift this one up by 1. So it's like this. And it goes down, and it's going to get closer and closer to 0, to the y equals 0 horizontal asymptote. So that is that one. You also have transformations of y equals 2 to the x. Let's call this minus 1. Excuse me. This is your horizontal shift. So that means we're going to shift to the right by 1. So I'm going to take my parent function, the purple one. Purple one is y equals 2 to the x. I'm just shifting it over to the right by 1. So I'm shifting this over by 1, this over by 1, and this over by 1, and everything on the other side over by 1. And if we're just sketching it, then it would be something like this. Right? So it just got shifted over by 1. Okay? You also can do the same thing with reflections, if this had a negative in front, and all that. Now, on our, let's do one with y equals 1/2 x. Alright, so we already kind of know. Let's go look and see what that one looks like again. We already know what that looks like. It's kind of the reflects over the y equals x. So I'm going to graph that one. So we still have this. Negative 1 would go to 2, 2 goes to 4, and 4 goes to 8 somewhere up in here. Probably about there, so it's like that. Okay, so there it is. That's the parent function. Now if you want to do a vertical shift up, that would be to the x. Let's shift it up by 3. We can see it better that way. I'll do this one in green. So this one is x to the x plus 3. So all I'm doing is shifting all these points up by 3. So I'm going up 3. 1, 2, 3. This one goes up 3. 1, 2, 3. This one goes up 3. 1, 2, 3. So basically it's something like this. Sorry. And it's going to keep going down and down, and it doesn't cross. So we just shifted this whole thing up right here by plus 3. And if I wanted to do a horizontal shift, then let's shift this over to the left by 4. So that's going to be plus 4. And we'll do this one in red, sorry. 1/2 x plus 4. So I'm shifting everything. I'm going to shift my parent function from here over by 4. 1, 2, 3, 4. This one is 1, 2, 3, 4. I shouldn't have done that because now I'm going to run into this. But anyway, it would be something like this. It should just, the whole thing just shifted over by 4. Okay? And that's just basically your transformations. And you can also have stretches and all that good stuff, but this is the basic concept. Now when you get to e to the x, the main points you want to remember on e to the x are these points here. You want to remember 0, 1. Right there. You want to remember 1 and 2.72. So this is 2 right in there. You also want to remember negative 1, 0.37. So here it is. And the reason you need to know that is when we do logarithms, you need to know those. So it basically looks like the others. So basically our points we used are 0, 1, 1, 2.72, and negative 1 at 0.37. So that's y equals e to the x. If you want to shift it up by, what do you want to shift it up? You want to shift it down? Let's shift it down. E to the x minus 4. So from here I'm just going down 4. 1, 2, 3, 4. From here I'm going down 4. Right about here. And basically this is going to be down 4. 1, 2, 3, 4. So it's kind of close in here. You know I can't draw. Anyway, it's something like that. So your horizontal asymptote got shifted down. So your new horizontal asymptote is y equals -4. And then if you want to do a horizontal shift, let's do that in red. Let's go this way this time. So we're going to do x. Let's do -3. That means that's a horizontal shift to the right by 3. So from here you're just going over 3. 1, 2, 3. From here you're going over 1, 2, 3. And from here you're going over 1, 2, 3. Now I can't even see what I did. So I'm going to start, we went here 1, 2, 3. So basically it's going up like this. And it got shifted from here to the right by 3. This one got shifted down by 4. So that's -4. And that is your transformations.